Hello, this video is to help demonstrate kind of how I want you to upload your work and give you a little bit of insight into what it means when you're asked to upload a graph, when you're asked to interpret something in context, and what your turn-in homework is going to look like roughly for this online class. So on our online class, I've created this sample assignment. You do not have to do it. I've created it only as a reference so that I can show you some types of questions that you'll be asked and what the expectation is for the work that you will be submitted. So on this assignment, I'm going to go to teacher. Again, you don't need to complete this. This is just to show you what the expectations are for when you are uploading your work for your turn-in homework. Your turn-in homework will be similar to your online homework, except for I will require about a third of the points will come from the work that you've shown. So you could get everything right and still fail these assignments if you're not showing appropriate work. So it's very important that you understand what the expectations are in order to receive the maximum amount of points on these assignments. I believe that learning how to communicate in the world of math is an even more important skill than just being able to type things into a calculator, get a numerical answer. I want us to interpret answers. I want us to communicate how we get our answers so that we can show other students or down the line, be able to explain how we get the answers that we've calculated. So this first one is something that you're most likely going to see early on with descriptive statistics, where you're asked to interpret something in the context of the problem. So here we took a survey of Missoula College students, the number of credits, and we found the following one variable statistics. So a mean of 14.78 credits, a standard deviation of 2.5 credits, and a median of 14 credits. We're asked to interpret the median in the context of the problem. It's very easy for us to just say, oh, the median is 14. We've now identified the median. That's great. That's kind of like level one of interpretation. However, it doesn't really tell us anything about the median. It doesn't even include units. It's just a number. Like, numbers don't really exist unless they have some sort of unit associated with them. So we know that this random variable we're discussing is the number of credits that students are taking. So we could say, well, 14 credits. Now at least I've given a unit. This is another sort of level in our interpretation. We've included units. However, we need to go further because we want to make sure that we describe what the median is. And the median is a value at which 50% of our data is below and 50% of our data is above. So sort of the next level is to include that piece where we would say 14 credits, half of our data is above this value and half is below. The problem with this sentence, half our data is above this value and half our data is below, is it doesn't include the context of the problem at all. I could copy and paste this sentence, and anytime I'm asked to interpret a median, I could paste that sentence in and it would work. The problem is, what does 14 credits represent? Right? What does it mean that half of our data is above that value? What is our data? We want to include all the context of the problem in order to fully demonstrate our understanding. So if I wanted full points on this, an interpretation would be a complete sentence like the median number of credits that Missoula College students are taking is 14. This tells us that half of the student population is taking under 14 credits and half is taking over 14 credits. All right, we've now included everything about the context of the problem. We've got our units, credits here. It tells us half of our student population is taking under 14 credits, which is a lot more information than simply saying half our data is below this, half our data is above this. So another example, you'll be asked to interpret slope and y-intercept. So identifying the slope in the y-intercept, again, is sort of like the first piece. So the slope in this question would be 9.4 and our units. So since the percentage is our y value, our dependent variable. It's telling me that when x increases by 1, when 1 hour goes by, we would predict that the exam scores will increase by our slope value. So 9.4, the units on this are going to be percent per hour, right? Because a student should improve their score by about 9.4% for every hour that they study. Again, we want to do this in a complete sentence. So the slope of this linear regression tells us that for every additional hour a student studies, right? This is now saying in words, let's let our x, our independent variable, increase by 1. X increases by 1 additional hour a student studies. Our model predicts that their estimated score on the statistics exam will increase by 9.4%. We now have included everything. We've alluded to the change in x, additional hour of study, and the resulting change in y, an increase of their exam score by 9.4%. That will be a complete interpretation of the slope. For the y-intercept is the value of my dependent variable when my independent variable is 0. So this would be, we want to make sure we include all of that information and not just say the starting value is 55. There's no units there. That is, again, identifying the value, but it's not fully complete. So we want to allude to all of the pieces of data that when x is 0, the y-intercept of 55 tells us that the model predicts that when a student studies for 0 hours, their score on the statistics exam will be about 55%. And when this x value is 0, our y value will be the y-intercept. In a lot of instances, it won't make sense in a real world context, but I still want us to interpret it as if, interpret it in that context, interpret it as if this value were 0, then our y value would be the y-intercept. On questions like this, I will have to manually go in and grade your responses. So you will submit and you will not have credit until I go in and grade these manually. So question 2. This is something you will see in lessons 2 and 3, where you'll be asked to upload graphs. I just copied the exact question from lesson 2. So I am not going to be uploading a graph from Tour de France, but on CodeApp, I've created a graph here. You can click on the title to update the title. You needed to change like the max height here. You can change the title by renaming the column. You can play around until your graph, your image looks appropriate. There's more videos on how to use CodeApp. And then I'm going to click on the save the image. I'm going to export it as a PNG. I already did that. I already downloaded it. Right here is my rollercoasters.png file. I'll open it up so you can see what it looks like. Shoop, shoop, shoop. There it is, roller coasters maximum height. Title's at the bottom. You can see my histogram. And so I want to upload that file for this problem. That's going to be the way that we get points on this. So I'll go to my downloads. I will upload the file. So now I can see that file. And then you're going to type up a brief analysis. When I look at that graph, looks like it is right skewed, tails off to the right. And it looks like most of the roller coasters have an average height between, in between 50 and 150. That's taking up, so there's 30%, there's another 32%. So that's over half are in between. This is between 50 and 100. This is between 100 and 150. So I'm just going to write those two sentences. The heights of roller coasters appears to have a right skew to the distribution. Similarly, it appears that most roller coasters, roughly a little over 60%, have a maximum height in between 50 and 150 feet. But there's two sentences. Of course, don't, whenever you're asked to notice any patterns, please don't keep your observations that there's one value here and this was the highest. We can do a little better. Try and really look at the images that we're uploading and think about what we've learned in class so we can type up appropriate patterns. Again, I will have to manually grade problems like this. So you will submit. I'll be able to open up that file and read your answers. So question 3. This is now a question where you are going to solve the question. You'll do some work. You're going to enter in your answer, and then you are going to submit your question. If you are wrong, you'll have 3 attempts. So if you are wrong, try again, but I only want to see your final correct answer. So you sort of have 3 attempts at getting the correct answer, and then you can make sure that your work is like final draft and matches the solution that you're uploading. So this question in particular, be sure you include a labeled image of the distribution you're using. When we get to some of the later questions, you will be asked to include a distribution as part of your work. To me, I think that's incredibly important to understand the connection between what we're typing into our calculator and the actual area of a distribution. So if I am going to stop share super quickly so you can see what this might look like. So here was question 3. Right, so this is a perfect example of very well turned in work. I've rewritten the question, which is going to be very important. So I know what the question is asking me. I've now included a distribution. In this case, we're told it's normally distributed. Some of this doesn't make sense. It will by the end of the term. So I drew my normal distribution. I labeled the mean. I went out 1 standard deviation in each direction for scaling. Again, that's very important. And then we are asked specifically about 43, so I've labeled that 43 and shaded the appropriate region. I'm looking for tires lasting more than 43,000 miles. I've also included the proper notation, probability that X, my random variable, is greater than 43. And then here's what I've entered into my calculator to get the answer. Then part 2, it would say, yes, it's unusual. The probability of this happening, this being a tire lasting over 43,000 miles, is 1.31%. Something to note, I have left plenty of space for feedback. If I'm going to be giving you feedback on the work that you're submitting, and I need to have room to write the feedback. If you're using lined paper, I need you to skip lines between every step of your work so that I can write comments and give you that appropriate feedback. So here's a really nice example of the distribution and the work that is supporting our answer. I'm going to go back. So we got 0.0131, and we said that was unusual. We'll submit. Look, we got it right. Now, if we had gotten it incorrect, we would want to update our work. And again, if you're doing scratch work, that's fine. I only want to see the final draft. I want to see the quality work that you are submitting for these types of problems in order to get full points. On question 4, this is now a binomial type question. Again, I have my work that I can show you as a good example. So we'll stop the share here. So you can see, again, I've written out the statement of the question. And here is my work. So I don't just have the values. And here's the mu, here's the formula I'm using, the values plugged in, and my solution. Standard deviation, the formula I'm using. Right, there's a little bit of work or a little bit of space in between all of my work, and I have all of my answers and all of the work, specifically what I've typed into my calculator. Right? Sometimes you'll want to draw images to show your work. Sometimes if it's mostly calculator work and I only see numbers, there's no way for me to check whether or not your answers were correct. There's no way for me to really know that you understand what you're doing. And that I think is the most important piece. So again, here's a nice example of quality work, questions rewritten, there's space, things are labeled so it's easy to see. We could go back, type in all those answers, hit submit, make sure that we have the right answer before we upload the work of potentially an incorrect answer. Also, if you get it incorrect on all 3 attempts, you can still try and submit the work and get those points, even if you miss those initial points. Your work doesn't have to match one of your 3 responses. However, if it does match the answers that you've submitted, I can then check for mistakes and give you feedback. So kind of up to you in that regard. So before I go to how you will upload your work, I want to show you some bad examples. So here is question 4. This is that binomial question I just had. I do not want to see this. These are a list of the answers. There is no work whatsoever. I will give no credit. There is no retyping of the question. I don't know what question you're trying to answer. If the numbers are different, there's no way for me to check your work. You're either wrong or you're right. You will receive no credit for this work being submitted. This is what you're going to be typing into the problem anyway. This has a rounding error and it will likely be marked wrong. And there's no way for me to verify what that error was. I did another example. I was trying to squish together work, no rewriting the questions, just this one doesn't have a distribution. I'm squishing everything in and makes it difficult for me to write feedback. Again, you are not going to get full credit if you are not following the instructions and uploading your work in a way that gives me feedback. Lastly, here's another example of something I do not want to see. I do not want to see all of your scratch work. I do not want to see really messy, unlabeled, difficult to read solutions. Questions should be labeled. The questions should be rewritten, and your work should be neat and easy to follow. I like to grade as if you were giving this assignment to one of your classmates who has the same level of knowledge as you. And I want it to be a final draft version. So another student in the class should be able to look at your work, understand how you got your solution, and then understand what your solution is. If I don't believe or you don't believe that you could hand this to a classmate and they could understand how to get the appropriate solution, you are not going to get full credit for your work. So finally, the first couple questions is really not work to be shown. It's a lot of essay responses, but later on it becomes more mathematical heavy and there will be work. So it'll look more like question 4 and question 3 with those distributions. And what you will do is you will upload a file and it has to be a PDF. So I have already, as an example, I took pictures of this work. This is one option. If you can use a scanner to scan straight to a PDF, great, that's even easier. But another option for those of you who might not have access to a scanner, but have the ability to take a picture of your work, make sure that I can see all of the work on that page. You don't have to do a new page for every single question. These ones just happen to have a lot more work. But so I have 2 different images, and what I'll do is I will download both of those images. I will upload them onto a Word document. Everyone should have access to Word through your student account. And what you can do is now insert pictures. So I'm going to say I'm going to insert pictures from this device. I'm going to go to my downloads. I'm going to insert that first picture. There's my first page of work. I can now go to the next page, say insert pictures from this device. I'm curious. Oops, I downloaded the same one twice. Okay, so sorry. Let me go to the binomial question and let's download this one. But now I can upload this image onto this page. Right, again, it's nice and legible. And I can say File, Save As. I'm just gonna save it to my desktop for now. Actually, I will save it under my online stats class. Let's see, Missoula College, online stats, sample work. I'm gonna say save. Oops, I saved it as a Word document. I want to save it as a PDF. So save a copy. Make sure you save it as a PDF. Because I want to see the uploaded PDFs. That's going to be the easiest for me to start marking. So it should be one document, should not be multiple documents. And this is one easy way to get all of those images if you don't have a scanner. If you have a scanner, again, that will be easier. If you do not, you can take the pictures, make sure that they're legible, make sure you can see, make sure that they are appropriately sized, put them on a Word document and save that Word document as a PDF. So I want to upload my work now on my OpenMath. So I will say choose file. You will do the same thing for your exams. You'll upload your work afterwards using one individual file. I'm going to go to my documents, Missoula College, online stats. And here is my sample work. I'll say upload, submit question. And now I'm done. It has to be graded. So until I grade it, and I will provide you with feedback once I have graded it. But now that is how you can upload work. If you have other questions, if there's anything else that's unclear or you're unsure, or you want me to take a look at your work and see if it is of appropriate nature, please send it my way before you submit it, and I will give you some feedback in advance. Otherwise, good luck getting started on the class. See you soon.